Aromatic compounds are benzene and the compounds that resemble the structure of benzene in what manner? In the chemical behavior. Means any compound which will resembling the structure of benzene as well as during chemical reaction they will follow the properties of benzene molecule. Aromatic properties are those properties of benzene that distinguishes it from the aliphatic hydrocarbons. What we have discussed just now, aliphatic compounds are those which will contain carbon-carbon single bonds. These are generally cyclized in nature. They are saturated, they are unsaturated, they are linear compounds. But these are the families of compound. That means aromatic compounds will show a distinct behavior from the aliphatic compounds. Now, what are those? Some compounds that possess aromatic properties. Now, we have discussed just now the meaning of the word aromatic means they will give the fragrance and have structure that seem to differ considerably from the structure of benzene. Actually, however, there is a basic similarity in the electronic configuration. What is the meaning of this statement? All aromatic compounds generally will not resemble the structure of benzene, but during chemical behavior they will behave like a structure of benzene in terms of what? In terms of electronic configuration. Now, again we will discuss about aliphatic compounds. Aliphatic hydrocarbons, as we have seen, undergo generally what type of reaction? They are generally, now what are the examples of aliphatic compounds? They are alkane containing carbon-carbon single bond. They are alkenes containing carbon-carbon double bond. They may be alkynes containing carbon-carbon triple bonds. So these all are a family of compounds. Generally undergo what type of reaction? They generally undergo addition and free radical substitution reactions. The examples of free radicals are carbenes, carbanions, carbocations. So these free radicals will be substituted in the structure of those aliphatic hydrocarbons and they are generally undergo what type of reactions? Addition reactions. So addition occurs at what? Addition occurs generally at multiple bond. The meaning of the word multiple bond means we know aliphatic hydrocarbons contain carbon-carbon double bond and carbon-carbon triple bond. So these addition reactions occurs at what position? Generally at carbon-carbon multiple bonds, and free radical substitution reactions occurs at other point along with the aliphatic chain. So free radical substitution reaction will occurs at the terminal endings of the long chain carbon containing compounds. But in contrast, we shall find out that aliphatic hydrocarbons are characterized by tendency to undergo what type of reactions? Heterocyclic substitution reactions. See here the comparison point of view. Generally aliphatic hydrocarbons will go for what type of reaction? They will undergo addition uh, as well as there is addition of free radical substitution reaction, whereas the aliphatic hydrocarbons undergo basically what type of reactions? Heterocyclic substitution reactions. We shall find out this contrast, that is a comparison point of view maintained in other families of compounds that like acids, amines and aldehyde. Now what is the meaning of this statement? Aliphatic hydrocarbon will go for addition and substitution reaction. Aromatic hydrocarbons will go for heterocyclic substitution reaction. Now this property is generally given by what type of compounds? Acids, amines and aldehyde. The hydrocarbon part of their molecule, which molecules? Acid, aldehydes and amines, undergo reactions characteristic of either aliphatic compounds and aromatic compounds. Means these functional group containing compounds will go for both addition reaction, free radical substitution reaction as well as heterocyclic substitution reaction. But while we are comparing aliphatic and aromatic compounds, aliphatic go only for addition and free radical substitution, whereas aromatic aromatic compounds only go for heterocyclic substitution. Now I am proceeding further. Now we are interested in discussing the structure of benzene. What is the structure of benzene? Now it is on the slide. We know the structure of benzene is very well known to all of us. Now what is the structure of benzene? It is obvious from our definition of aromatic compound that any study of their chemistry must begin with the study of benzene. Whenever we are going to start the structure of any chemistry compound, we must start with the structure of benzene. Benzene has been known since, so it is discovered in 1825, and its chemical and physical properties perhaps better known than those of any other single aromatic compound. So he is going to behave in drastically changed manner as compared to other organic compound, and it is discovered in 1825. In spite of this, no satisfactory structure for the benzene had been advanced or it is discovered till 1931. See, it is discovered in 1825, but up to 1931, we don't know the structure of benzene, and it was just 10 to 15 years. The structure was generally used by the organic chemists. Now, the difficulty was not the complexity of the benzene structure. See, the structure of benzene is too compact in nature. He is going to possess a carbon-carbon alternate double bonds, and those alternate double bonds continuously delocalizes from one carbon atom to the another carbon atom. See, I am going to provide you the PPTs later on, so don't be busy while taking the screenshots. While you are going to take the screenshots, the slide is going to, or there is something writing down in the slides. So please cooperate. Okay. Now we are proceeding for the next step. So the structure of benzene is too compact. He is going to possess, or the structure of benzene is going to possess carbon-carbon alternate double bonds, and this delocalization of double bond is continuously taking place from one carbon atom to the another. So the difficulty was not the complex structure of benzene molecule, but rather the limitations of the structural theory as it is so far developed. Since the understanding of structure of benzene is important both for our study as well as for the study of aromatic compounds. So we are going to extend our knowledge from structural theory. We will examine some detailed facts about the structure of benzene. Now, what are those detailed facts about structure of benzene? We are going to study the molecular formula, the isomer number for the benzene, and a very clever scientist, that is Kekulé, has given the structure of benzene. Now, how he has derived the structure, that history we are going to study in forthcoming slides. Now, benzene has a molecular formula we know, that is C6H6. From its elemental composition, see, what are the element composition or elemental composition of benzene? He is going to possess simply carbon and hydrogen. So from elemental composition and molecular weight, how we are going to calculate the molecular weight of benzene, as he is going to possess 6 number of carbon atoms and 6 number of hydrogen atoms. Now the question was, how are these atoms arranged in the structure of benzene? Before 1831, the Kekulé